Here we go.
Okay, so 9.1 is looking at different ways that we can graph on the calculator, and we'll do some stuff by hand, besides y equals and a function. Right? So parametric is the first method we're going to look at.
Will we need graph paper on the
I don't think you'll need graph paper. Most of the graphing is going to be on the calculator.
Okay.
So, just to show you some different kinds of graphs, some of these are a little bit fancier than we're going to look at, but the idea is you can draw things parametrically that we can't do at all with y equals. Remember, y equals, we can't draw things that fail the vertical line test. I mean, even a circle. We can kind of cheat and draw like the top half and the bottom half separate, but we can't draw a circle.
Oh, that's a butterfly.
Yep, so there's another shape you can draw parametrically. I don't know the formulas to do those.
So we're just doing art with math equations?
Yes.
Okay, that's kind of
And there's another one. So we will look at something like this if we have time later today. I think kind of like that.
looks like candy.
So what is a parametric? Well, let me show you on the calculator first. If you go to mode, the mode that we've been graphing everything in is function. What we're going to look at today is putting it on parametric. Okay, so if you put it on parametric, right, you just go to it and hit enter, and then you press y equals. It's going to look a little bit different. So you still have spots where you can graph things, but notice to graph, say, just something in blue, there are two equations. When you do something parametrically, you have a set of equations. And the idea is you have a formula that's going to generate the x values in your coordinates, and you have a separate formula that's going to generate the y values. So parametric uses two different formulas to create a picture. One formula controls x's, one formula controls y's. So totally separate.
Two questions. One, what is the t?
We're going to talk more about t, yeah.
Okay. Second question. Why does it say a plus bi?
Oh, I think I'm in complex mode.
Okay.
That's it.
I didn't know if that was normal if we were going to have to use complex.
Yeah, it doesn't
numbers.
matter
I
if
was
you're
gonna start
in
crying.
real mode or complex.
No, it doesn't matter.
Okay.
I was going to start crying.
So in parametric, we have two equations. We usually give them a name, like let's call one of the equations f, and we'll call the other one g. When we do a problem, it's going to be given to us like this. This is a set of parametric equations. I'm calling this one x and this one y. This formula is controlling what the x coordinate is. This bottom one is controlling the y coordinate. And somebody mentioned about a t. We'll talk about what t is. It's like your variable. All right, so we've got two different functions. One controls the x values, one controls the y values. If you take all the different coordinates, or all the different x values generated by this formula, and then you take all the y values generated by that formula, and you put those x and y values together as ordered pairs, and you draw it, you get a picture called a parametric curve. Even if it's a straight line, our book still calls it a curve. It's like a parametric curve. So a curve is just any picture that you've created using parametric equations. Yes?
So it's like two different functions.
Yep.
But then like more specific.
Yeah, it's two different functions, and one function controls x values, and the other function controls y values. So they're totally separate.
So in that case, both the x and y are dependent.
Well, you'll see.
Okay.
So when you have two equations creating a picture, we call that a pair of parametric equations. And these would have to be formulas, like I showed you on another example. Now, the variable that we generally use, and this is the, like, I guess you could think of it as that independent variable. That's t. T is the number that you are plugging in for. Like normally, x is the number you plug in for. Well, in parametric, we just call it t, but it's the same idea. The other thing you'll notice is if you go to y equals and you press the button that normally gives you an x, when you press it now, it gives you a t. So t is the variable you always use when you're doing parametric. And you can call t a variable, but really the name of it is it's called a parameter. And when we start graphing parametric equations, we are very specific about what the parameter can be. Normally, when you write an equation like y equals 2x plus 6, you don't put restrictions on what x can be. The assumption here is x could be anything you want. A positive, a negative, a fraction, a decimal. You could pick anything. When we use parametric equations, we don't allow people to pick anything. We're very specific, and we say something like, you can pick a value as small as this, and you can pick a value as big as this. And that's what you're allowed to use. And not only do we specify how small and big it can be, but we also specify what you're allowed to pick in between. So let's say, like I said, you could pick a value as small as 0 and as big as 10. And I'll allow you to go by ones to get from 0 to 10. That means you could pick 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I could say you could pick as small as 0 and as big as 10, but you can go by 0.5s. So then you'd be allowed to pick 0, 0.5, 1, 1.5, 2. So we're very specific about what you are allowed to pick for t. We give a minimum, we give a maximum, and then we give what types of numbers in between. Yeah?
Is t in like the equations x equals y equals, is t the same?
Yeah, you'd have to pick, like if you plug 3 in here to get the x value, well, to get the corresponding y value, you'd have to plug the same value of t in here. So they'd have to be the same. Yeah. So when you take a picture, it's another vocabulary word, and you describe it with a pair of parametric equations, you can say that those equations give you a parametrization of the curve. So if I gave you like a picture on a test, and I said for you to find a pair of equations parametrically that matched what the picture is showing you, you would be finding a parametrization of the curve. Writing parametric equations, that's what it means. Now, we saw that curves can intersect themselves. When you have parametric equations, you can get curves that cross back over. You can get spirals. You can get all kinds of things. Graphs intersecting themselves is not a thing that normally happens when we do y equals. In fact, it doesn't happen. Because the calculator can only draw functions. If something came back and crossed itself, well, then it would fail the vertical line test.
Wait, so they can or can't intersect?
Can. They can. Yeah, just like any of these pictures here. Parametric curves can cross over themselves multiple times. Depends on what you sketch. I'm not saying they all do. Like you can draw a circle parametrically, and if you draw a circle and you stop right there, well, that never really crosses over itself. Except maybe if you count where it starts and where it stops, it's the same point. So, big difference about parametric equations is kind of what I've already told you about the parameter. we are very particular about where the parameter starts and stops. That's like your domain. Because you're controlling what values you can plug in, that means parametric curves generally do not go on forever. They start somewhere and they stop somewhere. Where do they start and stop? Well, it depends on the parameter. How small of a value are you going to let me pick? How big of a value are you going to let me pick? That's going to control where I start and stop. So like if I was doing a spiral, it might start here, it might stop there. Or if you allowed me to pick a little bit bigger value, maybe I could get another revolution out of it. Depends how big you're going to let me pick. That would be considered the start. That's the stop. And notice, just because you know the start and the stop, that doesn't tell you how to get from the start to the stop. Could be as simple if it starts here and ends here as a line segment. That'd be the simplest way. Or maybe it's spiraling. Or maybe it's, who knows what it's doing. But to figure out what it actually looks like, we're going to need more detail than just, bless you, just the start and the stop. So on the calculator, we'll graph points in between, and that'll show us the picture.
Can you have a parametric curve that's like, because you had said it can count by ones, it can count by one, can you make it so that it counts like every point in between?
Well, you can do enough points that it draws a good picture. Obviously, it's impossible to do infinite points, but you have to pick a number that it's going to go by in between. If you start graphing on the calculator and you try to graph like thousands or hundreds of thousands of points, the calculator is going to freeze. So then you're going to have to stop it and turn it back on. So I'll freeze mine on purpose and show you what happens. And then I'll show you how to avoid that. All right, so how do you figure out where your graph starts and stops? This is the minimum value for your parameter. Your parameter is going to be written as an interval, like this problem. It's going to tell you what your domain is for your parameter, the low and the high. The low value, or the minimum value, is going to control where it starts. The maximum, or the high value, is going to control where it stops. So to figure out where it starts and stops, you need to find four things. Starting x value, starting y value, ending x value, ending y value. There's four things. To find where it starts, take the minimum and plug it into the formula you have for x, and then take the minimum and plug it into the formula for y. That'll give you the coordinate of the start. To get the stop point, you're going to use the formulas for x and y, which might look something like that. And for t, you're going to plug in the maximum value. That'll tell you where it's going to stop. Plug b in to the x formula, plug b into the y formula. And that's the first step for graphing a parametric equation, at least knowing where it starts and stops. Then the next step is to get some points in the middle. But let's see if we can figure out where something starts and stops. Okay, so here is our set of parametric equations. This is the interval for t. It is controlling what numbers I am allowed to fill in for t. We're not used to that. Normally we allow you to plug in any number you want. Except numbers that would cause you to like divide by 0 or take the square root of a negative. We always avoid those. But we're even avoiding other numbers that would work in these formulas because they said to. 0 to 1. So find the endpoints of the curve. Okay. What value is going to control where this graph starts. Yep,
The 0.
the 0. So you need to plug the 0 into both formulas. Plug it into the x formula and the y formula. And we need to do that out. What do you get if you plug in 0 for t in the x formula? Yep, 1. So this graph is going to start at 1, comma, and what do you get if you plug in 0 in the y formula? 2. So it's going to start at 1, 2. And it's going to end. Well, what number are we going to fill in for t to see where it ends?
1.
1. We're going to plug 1 into the x formula. And we're going to plug 1 into the y formula. What do you get if you plug in 1 for t in the x formula? Negative 1. And what if you plug in 1 for t in the y formula? 1. Because that's my maximum for my parameter. You always plug in whatever number they give you right there. And it's usually brackets. Bracket means you can include the 0 and the 1. So think about those 2 points. Okay? 1, 2, and negative 1, 1. So we're starting at 1, 2, and we're ending at negative 1, 1. Now, does it just go straight between the 2 points? We don't know. In this case, it does. It's just a line segment. But think about when you draw something on the calculator screen. What direction does the calculator always draw in? Or what direction has it always drawn in?
Left to right.
Left to right. The screen has always started on the left and drawn to the right. It's not going to do that for this one. It's going to draw right to left. And let's see how you type this out. So first thing is you got to make sure it's in parametric mode. So you put it in parametric. Go to y equals. And put in your 2 equations. So x minus 2t. I'm sorry, 1 minus 2t. And 2 minus t. Now we have to control the parameter. We need to put in where it starts and where it stops. If you press window, you're going to see something new there that we haven't seen before. What's new? The t-step. The t-min, t-max. Well, the t-min and the t-max come directly from the problem. 0 to 1. And the t-step is the increment that you're going by to get from 0 to 1. So let's say I do a t-step of 1. Let's think how many points we'd be graphing. You'd start with t-min, so you'd graph 0. And if you increment it or step by 1, what's the next value? 1. Well, that's your max. Now you're done. So you just graph 2 points. Let's say you set your t-step to 0.1. You're going to start at 0, and then you're going to plug in 0.1 into both of these equations and graph that point. Then you're going to plug in 0.2 into both equations. Graph that point. 0.3, 0.4, 5, 6, 7, 8, 9, and 1. So if you step by intervals of 0.1, from 0 to 1, you're going to graph 11 points, which is more than you need for this picture. Yeah.
Is the so the number for the t-step, is that going to change the problem in any way?
Mm-hmm. Yeah. We'll talk about, especially when you do things like curve. If you don't have enough points on a curve, it doesn't look like a nice curve. So if I hit graph, well, it's probably going to go too fast, but let me do 0.01. So now what I'm doing is I'm graphing, what is that, like 101 points? It's going from 0 to 1, counting by hundredths. So it's going to graph probably kind of slow, but watch the direction. Right to left. Okay, it did draw right to left. And graphing 101 points is overkill for that. Okay? If you graph by tenths, It graphs it 10 times faster, and it looks exactly the same. There's no difference. Okay, so let's just keep that for a second. That's what your sketch looks like. Any question on finding the start point and the stop point? Okay. So sometimes what we want to do is we want to eliminate the parameter. I thought I had one more of those. Eliminating the parameter means to take something that's written parametrically and convert it back to getting y by itself. Let's do that with example 1. The idea when you write something parametrically is you have two equations. To make it not parametric, we want to get it back to 1. So we want to merge these two equations back into 1, and we want to get rid of the t. How could I get rid of this t right there? And this is something you do in Algebra 1. Well, we don't want to isolate the t. I want to completely replace the t with something. How could I find something to replace this t with? Yeah?
You could use the other equation and you can solve for t in one of the equations and plug it in.
Yes. So we do want to solve for t in one of the equations, and I'll be specific. You want to solve for t in the x equation. If you're trying to get y by itself, solve for t in the x equation. So what would be my first step to solving this for t? Yeah.
You can subtract 1 from both sides.
Subtract 1 from both sides. And what's my last step? Yeah, and I'm going to write it out separate. So if I divide x by -2, I essentially have this. -1/2 x, that's the same as x divided by -2. And what if I divide -1 by -2? 1/2. Okay, so there's my formula for t, solving the x equation for t. Now take that and fill it in. And you're combining the two equations back together. So y equals 2 minus, and this is really substitution. That's all we're doing. -1/2 x plus 1/2. Okay, so what's that going to give me? What's -1/2 x?
Positive 1/2 x.
+1/2 x. And then distributing that negative, you get -1/2 and a +2. So what's 2 minus 1/2? 1.5, or what about as a fraction? 3/2. Yeah. So that is how you can draw as a function what we drew parametrically. Well, let's see if they look the same if we graph them. Let's save this first. Let's put that over here. And in order for this to work, you need to graph that and what we had originally using the same size window. But the nice thing is, if you set your window in parametric mode and then change it to function, your window stays the same. It should be -8, 8, -5, 5. Let's just check it. Put it back in parametric. Window. Yeah, -8, 8, -5, 5. So those mins and maxes carry over when you change modes. Why did they pick -8 and 8? I don't know, that's just what the calculator was already set up. Okay, so let's put it in as a function. Let's graph that and see if it looks like what we just did. 0.5x plus 1.5. Just easier for me to do decimals on the calculator. Okay. So did we get the same picture?
No.
It's what?
One has endpoints. One has a start point and an endpoint, and the other doesn't.
Right. So part of converting something from parametric to function is not only giving me the formula, but telling me where to start and stop that formula. Because parametric starts and stops somewhere, so you need to tell me where I should start and stop. And how do we know what the restriction is that we should use? Well, we already practiced finding start points and end points. So if you go back to the one we just did, look at the x values. You should only be drawing this graph between -1 and 1. That's the start and the end. So if you're going beyond -1 to 1, don't. Stay between -1 and 1. And I can tell the calculator to do that like this. Oh, once you copy that first. Okay, so you got your function, that's good. But now you need to tell me where to restrict. So if you didn't find your start and end points already, you need to go find them now. But we already have them. So the way you restrict it is you put it in parentheses. Just like this. And then next to the parentheses, you're going to fill in the condition that you want it to follow. I want to stay between -1 and 1. So I'm going to put x. And if you press second math, you can get a list of inequality symbols. I want to be greater than or equal to -1. And I want to be less than or equal to +1. And stay between them. So x, second test, less than or equal to +1. Now, it's not going to be perfect, but it's as good as I can do. It's still going to draw on the axis, but don't focus on the part that's on the axis. Just focus on the part that it actually sketched. And let's compare that to what we had. Okay. Ignoring what's actually on the axis, do those two above and below each other look the same now? Yeah. Again, just go like this so you can't see it if that helps you. Now it's not there. So what I really need to add to this one right here is x is less than or equal to 1 and greater than or equal to -1. I need this condition with that. All right, let's try another one of those where we eliminate the parameter. Okay, so I want to eliminate the parameter here. Let's find the formula first, and then we'll worry about any restrictions at the end. What's my first step to finding the formula with y by itself and no t? Solve for t and which equation? X. So what does that give you here?
T equals x plus 1.
T equals x plus 1. Now, what do you do with that x plus 1? Put it where t is. And now you'll have a formula without t. It's y equals x plus 1. Sorry. So there's your formula. But we know that the original problem had a restriction. That restriction needs to be carried over to this formula. This is not the restriction on x. This is the restriction on the number you're plugging in for t, which gives you x. So we don't have to worry about the y formula with the restriction. The y formula is for range. We're worried about restricting domain. So I need to find the smallest value. So what would I plug in for t to find where this graph is going to start? 0. And what's 0 minus 1? -1. So this is going to start at an x value of -1. It's going to do a bunch of stuff. Who knows how it's going to get to the endpoint? But now I need to know where it stops. What number do I plug in to see where it stops? 3. And what's 3 minus 1? 2. So this is the graph. I mean, I know it doesn't look like this. It's a parabola, shifted right 1. And the parabola is only going to be drawn between -1 and 2. So it might look something like start here, stop here. Might look something like that. It's a section of a parabola. Okay. Any question on that? So that's called eliminating the parameter. Now, it's not always possible to eliminate the parameter, because eliminating the parameter assumes you have an equation where you can get the t by itself. If I gave you one like that, you can't get t by itself. It's impossible. The problem is you've got a t as an exponent and you've got a t out in front. If you just had a t as an exponent, then fine, you could use a logarithm. If you just had a t in front, well, that'd be even easier. Just subtract 3 from both sides. But the problem is the t in both spots. So there is no way to eliminate the parameter here. So it's not always possible to eliminate the parameter, but it is always possible to go the other way. You can always take something that's not parametric and make it parametric. And I'm going to show you kind of a cheap way to do that. And it's not really cheating. I mean, it works, but it's kind of it's a clever way to do it, but it's not really something that's super useful to do. But let me show you. So if you want to take something and make it parametric, all you have to do is write 2 equations. One of them is x equals, one of them is y equals. If you just let the first one be x equals t, and then let the second one be whatever your formula was before, and change all the variables to t's, that's a cheap way to make it parametric. And I'm going to show you with an example.
Is this worth writing down, or?
I probably will ask you to do it, and I know, yes, it is in the homework. Yeah. So to make something parametric, just put down x equals t, and then write y equals, and change all your letters to t's that were x's. And technically that works. So let me try to put these up at the same time. All right, I want to write that equation parametrically. So what does it say to do for the x equation?
X equals t.
Just write x equals t. And what would the y equation be? Yeah.
Y equals 3t to the 4th plus 7t to the 3rd minus 8t to the 2nd plus 2.
Yeah. And if you're not sure why that works, think about if we were changing it back again. The first step to eliminating the parameter is solve the x equation for t. Get t by itself. Well, this equation already has t by itself. What does this top equation say t equals? T equals x. Now, you substitute that in everywhere you had a t. And if you substitute in the top equation into the bottom, you turn it back into what you started with. So it's just kind of a cheap way to make something parametric. There was no restriction on the domain here either. So you wouldn't have to worry about limiting your interval here. You could say t is all real numbers. So there'll be a few questions in the homework where you have to write something parametrically. And is that the only way to do it? No. Is it the simplest way? Yeah, definitely.
Yep. So when you do this, would it look like a completely different equation?
No, these would look identical. They're the same thing. you'd have to type this in under parametric mode, and you type this in under function. But yeah, the goal is to generate the exact same picture in different formats. Different formulas. Okay. Any question on that? Okay, so now let's start looking at something that curves. This is where it starts to get very important. We graph the right amount of points. Not too many, but not too few. And what is too many and what's too few? Well, there's no rule for that. Let's think about a circle. The whole idea of parametric is you are using two formulas to describe a coordinate. One formula is going to describe the x location. The other one is going to describe the y location. Let's pretend like we had a point right there. And you want to describe the location of that point parametrically. You would need one formula that tells me how far over to go. And then you'd need another formula that tells me the height, how high up to go. And if I do this, what would that be in this problem? That's my radius of my circle. Now, what in this triangle would be the thing that would change, that would control this point moving around to different spots? Well, the x and the y value would change together based on something else. No, the origin's that's just the location of where it starts. But there's something about that triangle you could change that would affect the x and the y value at the same time.
The angle?
The angle, yes. In this problem, that's what we call our parameter. It's the thing that's going to change, and as it changes, it will affect the y and the x at the same time. Now, normally we would call the angle a Greek letter, but what do we call the letter when we're doing it parametrically? What's the letter we use? T. T. So this angle is going to be T. That's my parameter. What trig function would involve x, t, and r? Yeah? Cosine. Cosine of t equals, and what would go on the other side? Yeah.
X over R.
X over R. And when we describe something parametrically, we need x equals, and then we need y equals. So what would x equal in this case? Yeah.
Cosine of t times R.
Yeah, I'm just going to put the r in front. So r cosine of t. R is a fixed value you would have to know in the problem, depending on the size circle they wanted you to draw. So you know that. R would be 2. I think we're going to do 2 in a minute. Yeah, radius 2. And based on the formula I just came up with for x, how do you think you would find, or what would be the formula for y? R sine t. Yeah. So these are the parametric equations that you use. Again, you need to know R to draw a circle. So now, I want to draw a circle that has its center at the origin, which is what these formulas are for. And the radius is 2. Anyone think they could give me the x formula specifically for a radius of 2?
Two cosine.
2 cosine t. And what about the y?
Will we always, just a quick question, will we always assume that our x and y will be in the same spots on the triangle?
Well, the only thing that could change is where they want the center of the circle. Well, the center and the sides. Right now, we're doing it at the origin. I think there is one in the homework that says, you know, instead of having it start at the origin, have the circle be up 3 units. So it's a little different, but all you have to do to shift it up and down is put like a +2 or something, and that would shift it up or down.
So would y be 2 sine t?
So let's put those in, and let's graph it. But this is where we're going to start to learn a little bit about how we set t-step. So put it in parametric, which I thought I did, but I didn't. There we go. 2 cosine t, 2 sine t. Now, t is a parameter. What values would you have to go through for t, starting with a minimum and a maximum, to get every possible value you could from sine and cosine before they repeat themselves? You need to move through the entire cycle of sine and cosine with the parameter. Yeah?
It would be 0 to 360.
We need to go 0 to 360. If you don't go all the way to 360, you are not going to get a full circle. So you have to go through all the parameters in one cycle of sine and cosine. And it repeats after 360. Now, what do you think about having a t-step of 0.1? That's pretty small. So imagine you have to count from 0 to 360 going by 0.1s. 0.1, 0.2, 0.3. How much?
3,600.
Yeah, it's like 3,600, might be 3,601 numbers. It's a lot of numbers. And if you hit graph, can still do it reasonably quick. It didn't slow it down that much, surprisingly. But if you set it to like, actually something is still going because that yellow circle is still going in the upper right. So if that's still going, I can't do anything. Oh, yes. It's drawing over and over and over and over and over itself. Why? Why is it? You probably can't tell, but the circle is getting thicker and thicker. It probably stopped now. Why did it trace over itself?
Because it doesn't have an end condition.
It did. I put in 360 as the end. So it is going to stop at some point. It's because I'm in radians. If I'm in radians, I shouldn't have gone to 360. I should have stopped at 6.28. So I went all the way to 360. So it's tracing over itself an extra 15 or 20 times. So I need to stop it. So second, off, now it'll stop it. Now I can press a button, and I can do one of two things. I can either put it in degrees, which I was very surprised at how quick it drew that, and this is why. Now it's drawing. Okay? It's drawing every single point from 0 to 360, going by 0.1s. Graphing 3,600 points is going to take way too long. So we're not even a quarter of the way there yet. So we need to stop it. And when you're going from 0 to 360, you could go by 1s, you could probably even go by 5s. 0, 5, 10, 15, 20. You're going to get a lot of points. And I think it's going to look plenty good for a circle. So how low could you go and still have it look like a circle? Well, I mean, if you go by 20s, 0, 20, 40, you're going to get less points. And it's starting to not look as much like a circle. Some of the edges are starting to get a little sharper. Yeah?
I was gonna say, like, what if you put a really high number where it doesn't? Oh, okay.
So what's going to happen
It's an
is
octagon.
it's just going to put points from the start to the end, and it's just going to connect them in straight line segments. So what if I did that? How many points would I get? Well, I'm going to start at 0, so it would plug in 0, 90, 180, 270, 360.
You're gonna get diamond.
Yeah, so it's not going to look circular at all. It's not enough points. So the idea is you want it to look the way it should, and 5 points isn't enough. The other thing you don't want to do is this. How many points would it graph if I set my t-step at 100? What's going to start with? 0, then 100, 200, 300. Well, 400 would be over the max, so we can't do it. So now what's going to happen is your last point was at 300. It's not going to be a closed shape because you didn't end where you started. So ideally what you want to do is make sure your t-step is a number that divides into the t-max. Like 2, 3, 5, 10, 20. Any of those would be okay. So that way, as I'm stepping, I will hit 360 if I step by 2s. If I step by 100s, I won't. I'd skip right over 300 to 400. Okay. And that's what happens if you go by 2s. So now you're graphing about 181 points, which is more than you need, but reasonable amount of time to draw it.
So what would happen if you put the T-max as 360? Would it just be a little?
It is 360.
Like the T-step is 360.
Well, if you step by 360, then you're going to get a point at 0, and you're going to get a point at 360. So you should just get 2 dots, and it's just going to connect them straight. But the 2 dots are going to be at the same point.
So it'll look like that.
So you're going to get a dot there, you're going to get a dot there, and then it's going to connect them.
So don't do that.
Yeah, don't do that because then it's just going to look like a dot if it even shows up at all. And it doesn't show up. Okay, so any questions on that? Okay, so that's a circle. So in the example we just did, the domain and range of this graph was -2 to 2 and -2 to 2. That's for the actual circle. But what was the domain for the parameter? What was the domain for the parameter? Yeah. Yeah.
0 to 360.
It was 0 to 360. If you don't let that parameter go all the way to 360, you're not cycling through all the different values you could hit in the cycle, and you're not going to get a full picture. So if I stop at 200, well, it doesn't finish the circle because I didn't go through all the values. So you have to go from 0 to 360. Now, if you go 0 to 720, I don't know if you're going to be able to tell, but it will trace over itself. Can't really tell. The way you could tell is if I go 0 to 720 and go by an amount that won't land at 720. Go by like 13s. Could you tell a little better that time? It traced over itself. And if the bigger you make this number, the more you could really start to see it mess up. Eventually it'll really start not even tracing over the same path. So it's going by 49s and it didn't land at the same point the first and second time. So you can really start to see it. But you don't want to trace over itself. You want to draw it one time, not twice. Okay, let's just try sketching that one and just see what it looks like. And this will be the last one we look at. So it says x is t cosine t, and y is t sine t. And they tell me I'm going from 0 to 4 pi. That's my Tmin and Tmax.
So you want to be in radians?
Yeah, unless I'm going to change that to 4 pi to degrees. We want to be in radians. Okay, now let's think about the window. We got 0 to 4 pi. I don't want to step by 49. That's awful. I would step by maybe 0.1. That's reasonable. It's about 100, 120 points, 125 points it'll graph. Now, what's the biggest that cosine can ever go? Like if you take the cosine of something, what's the highest cosine gets? As the range. 1. Now, if everything lined up just right, and this came out to 1, if that was as big as it could be, and that was as big as it could be, what's in the box would be 1. What's outside the box, what's the biggest t could go? Yeah, 4 pi. What's 4 pi times 1?
4 pi.
So 4 pi is a theoretical maximum that we're looking at. That value could never come out bigger than 4 pi. Because the biggest that can be is 1, and the biggest that can be is 4 pi. So let's set our x max to 4 pi. Now it's the same thing for the y max. The biggest that sine can ever be is 1. The biggest that t can ever be is 4 pi. And if those two things both lined up at the same time, the biggest y value you could ever get is 4 pi. Now, same thing with the minimum. The smallest cosine could ever be is what? Negative 1. And if this was the biggest, at the time this was the smallest, if that lined up just right, the smallest number that could ever come out of this formula is negative 4 pi. So let's put that in. And this is probably more than we need. So x max. So we're going to do 4 pi's and negative 4 pi's everywhere. And then to put negative 4 pi and 4 pi. So that should cover everything. If your graph goes off the screen, then adjust your mins and maxes to be bigger. But I can guarantee nothing will go off the screen here. It's impossible. Because I thought it through. Nothing will go off the screen. Guaranteed. And it stopped right there. So what we essentially got here is 2 revolutions of a spiral. That's what this one is. So example 5 is a spiral. And there's some other ones that we'll practice graphing, but I'll leave that for the moment. Any problem in the homework that says to sketch without a calculator, you don't have to do any sketches without it, because you're going to be able to use a calculator for everything on the test. I guess I could have just made that, I must have changed it, 1 through 5, 7, 9. I guess it's just 1 through 17. I think I had taken out 13 and I added it back in. So it's really just 1 through 17. Okay, so we don't have class tomorrow. So you have 2 days to do that assignment.